This video will cover for loops, which are known as the workhorse of the programming languages. So a for loop is quite nice because we start with the keyword of for, and you can see inside of the parentheses, we actually have all of the different components of our loop kind of put together all in one space for us. So the first part is where we initialize the variable that we're going to be tested, so an int I equals 0. Then we separate these by semicolons. Then next comes the condition, I is less than 10. Then we have I++, which is the increment of change. And of course, in between the curly brackets, we have the code block to run each time the condition is true. After the code block runs, then we come to the closing curly brace. Now, after the closing curly brace, this is where it gets a little weird because it jumps back up to the increment of change, which is that I++. After we do the increment of change, then we go back and try the test again and see if we should actually run the curly braces one more time. Now, we're going to shrink this down a little bit. So instead of I is less than 10, we're going to go for I is less than 5 because it's just less times we have to go through the loop, okay? Now, here's how it works. When we first start the loop, we run this int I equals 0 one and only one time. Now, this creates the integer I and sets its initial value to 0. Okay, so we're going to put that into our right-hand side. We're going to keep track of I and the output to the console. All right, so we have I is 0. Then after that, we come over and do our first test, and we say, should this loop even run once? This could not be, like we could get this as a false, which means we wouldn't actually run it even one time, okay? Now, this time, we're going to put in the value of I, so we're going to make that 0, and we're going to ask the question, is 0 less than 5? Well, this is a Boolean of true, and since it is a Boolean of true, we're going to go jump down, and we're going to run the curly braces, which is just one line of code inside of it, that console.writeLine, and we're going to write out the value of I. Okay, so this value of I gets output to the console, so that's going to be a 0. All right, now we come to the closing curly brace down there, and that's going to jump us back up to the increment of change, I++. Now, the current value of I is 0, so I++ adds 1 to that, so I becomes 1. Then after that, we come back and do the test with a new value of I, which is now going to be 1. So we say, is 1 less than 5? Well, this again is a Boolean of true, so we come down and run the curly braces one more time, and what that does is it writes that I value out to the console, so in our console output, we now have 1. All right, we hit the closing curly brace, we come back up to the I++, which now adds 1 to the value of I. So 1 plus 1 is 2. So now the current value of I is going to be 2. Now we do our test again. Is 2 less than 5? Well, this again is a Boolean of true. So we run the curly braces again. We output that I value to the console. So I is now 2. So that comes to our console output. We come to the closing curly brace. We bounce back up to that I++, which now gives us a value of 3 for I. So we do the test. Is 3 less than 5? Well, that's again a Boolean of true. So we again do our console.writeLine. We output the value of I, which is currently 3. So that goes in our console output. We come back down to our closing curly brace. We come back up to that increment of change, which is I++. So add 1 to the current value of 3. So that's going to be 4. Then we do our test again using our new value of I. So is 4 less than 5? Well, that's again a Boolean of true. So we run our curly braces one more time. We output our console.writeLine, the value of I. So the value of 4 goes to the console. We come down to the closing curly brace, which is going to be bouncing back up to that I++. So we add 1 to the value, which gives us the value of 5. Now we do our test again, and we have, is 5 less than 5? Well, this is a Boolean of false, because remember, 5 is not less than 5. 5 is the same as 5. Okay, so that's why this is false. So what that means is we do not run the curly braces anymore, so we will not do the console.writeLine, and instead, we're going to go on to the rest of our code down below, whatever that happens to be.
All right. So notice the console output is 0, 1, 2, 3, 4. Let's go ahead and jump back to the IDE and see this in action.
We're going to create a new solution for this one. We're going to call it For Loops. We'll put the little header at the top, For Loops, and we'll get started. So for this one, we actually don't have to do anything before we have the actual for loop. Like the while loop, we had to have that incremental variable. We had to declare it and define it. We don't have to do that for this one. So we just go ahead and start typing. So for open closing parentheses, open closing curly bracket, and split that apart. Now inside of these parentheses, we need three things. And I'm actually going to put this up there for you. So in between there, I'll go like this. We have the variable, the test, and then the increment of change in that order. And actually, these are separated by semicolons, so let me go ahead and make sure I put those in there instead of commas, because these are semicolons. That's extremely important. So first, let's have that counter. So let's int counter, and we'll set it to 0 to start with. Semicolon. Then we have a test. So let's do counter is less than 5. Semicolon. Each and every time around, let's do counter plus plus. Now that we have all of the three things set up, we can actually do the code block. And inside of here, all I'm going to do is just put a console.writeLine, open close, and a semicolon. And inside of here, the value of counter is, and we'll do the placeholder. So curly brackets with a 0 in it. Outside of it, a comma, and then let's put the counter variable. That is it. So now we go ahead and hit the run button, and we see the value of counter is 0, 1, 2, 3, and 4. And that is it. Now, for loops are great because we know how many times they're going to run because we're kind of setting up that right here. So they're used a lot for when we know we have to execute something a certain number of times. While loops are going to be great if we don't know how many times we want people to, or a loop to run. For example, if we ask people for a response, we don't know how many times they're going to mess up. So we need to give them as many chances as possible. Well, this is going to be more likely that you know how many times you actually want it to go through it. Now, this is an example of a normal kind of counting up, and probably 90% of your for loops will kind of look like this. They'll be incremented by 1, they'll start at 0, and they'll be less than some sort of number. However, they don't always have to be like this, so we could start them at, say, 10. We'll say, give it to me as long as the counter is, let's go with greater than 5. And then each and every time, let's do minus minus. So now when we run this, we get 10 because it's the starting value. So we initialize our counter variable, set it equal to 10. Then we come and do our test. Is 10 greater than 5? That's true. So we go and run the code in between the curly brackets. So we put that out onto the console. We come to the closing curly bracket. We come up here to the increment of change and do minus minus. So then counter minus minus becomes 9. Then we do our test. Is 9 greater than 5? True. Then we do the line right here again. Come back down here. 8, 7, 6. As soon as we get to the value is 6, then we come to the closing curly brackets, come up here to the value of 5. Is 5 greater than 5? That would be false, so then our loop should stop. So that is why the last thing it prints is the value of counter is 6. So we can kind of have it any kind of incremental change we want, and we can play with these numbers to give us the exact numbers that we're looking for. However, what happens if we kind of mess up our numbers? So what if I say counter equals 10, and as long as counter is less than 5? Now, the thing about this one is, when we will run it, you'll see, and this is the new one, this is the old one, when we ran it, nothing was printed out. Because if counter is 10 less than 5? This is false. So as soon as this is false, the loop will stop running. So because the initial value was false, it never actually printed anything to the console. So that's why we kind of stopped it. Now, what if we have something different where I say, well, what if the counter is less than 11? So 10 is less than 11, so that should run. So then the problem with this one is we start getting giant numbers, and this will never stop because it's one of those infinite loops that we talked about. Because since we started at 10, is 10 less than 11? True. And then we subtract 1. Is 9 less than 11? Is 8 less than 11? 7, 6, 5, 4, 3, 2, 1, 0. Negative 1? Is negative 1 less than 11? Sure. Is negative 1,000? Sure. Is negative 7 billion? Sure. Any negative number is going to be less than 11. So this will run forever. So if you get this, just hit that X and just hit close because you do not want an infinite loop. So you want to try to avoid this at all costs. So generally speaking, your counter is usually going to be starting at 0. You can say counter plus plus here, and then you can do it as many times as you want. Just know that it's always going to start with the 0 and then count it from there. However, does it have to start with 0? No. We could start with 1. Sure. So then we got 1 to 10. Okay. How about if we do 5? What numbers will that give us? That'll give us 5 to 10. Okay, great. What if I want even numbers starting at 0? Okay, well, instead of plus plus, then I would just do plus equals 2 because I'm just adding 2 to that number. So then I get 0, 2, 4, 6, 8, 10. I would suggest you go ahead and try some of these numbers in different combinations and see what possibilities there are for this. And the other thing I would do is actually try this in here, this condition. Why not make it equal to less than or equal to? So sure, how about counter is less than or equal to 11? Does that help us here? Not so much because the last one is 10. But what if I had it go to plus plus again? If I did plus plus, then now it'll give us 0 to 11 because is 11 less than or equal to 11? That's true. So then it will run for the last time. As soon as it turns to 12, is 12 less than or equal to 11? Well, that's false, and so that's why it stops. So I would encourage you to try all the different values. Try starting at different values here. Try different conditions, and try different increments of change. And the for loops will actually work for you.
We have to figure out when to use each of the different types of loops. So in this class, remember, there's going to be 2 different types of loop. The for loop that we just talked about, and that's going to be the workhorse. So basically, anytime you know how many times you want to run something, so for example, if you have to run it 5 times, or if you want to cycle through an array or something like that, then you're going to use a for loop. Now, you're going to use the while loop when you don't know how many times you're going to be looping. Right? So a good example for this is when we are prompting the user or validating the user because we don't know how many times that the user is going to type in a wrong value. So while they're typing in the wrong value, then reprompt them. Okay? So that is when basically could use the 2 different types of loops. Now, they are slightly interchangeable depending on how you do your code, but generally use this guideline and you should be fine.